Okay, welcome back. So this is 23D part 2, and I'm really glad I took a break and I learned something, which is a good thing I looked at it because anyway, so what we're going to do, when you need to find a range, a probability over this range, that was this mysterious binomial CDF that I was wondering about earlier. So that's going to, let's clear this. Second bars go down. This one, the CDF, so that's for cumulative distribution function. That's the one we want when we have an interval or a range of values that we need. So we'll do that one. And it's still mpr, basically. The r, though, is the 2 here, because it's understood that it's going to be x is less than or equal to, like I was saying earlier. So we'll go ahead and type in n, which was 5, p, which was 0.72, and, whoops, I've been having trouble with this thing today, typing what I want it to do. And then r, you're going to plug in this 2 here. Oops. 2. And hit enter. And then then it's going to be 1 minus that. So 1 minus second answer. Enter. Okay, 0.862. Let's double check and make sure that that's correct. Okay, yes, that is correct. Just kind of double checking here with the book. 0.862. So that was 1 minus binomial CDF for cumulative distribution function, n, p, and the r is the 2. So that would be 5.72 and then that 2 there. And it's understood that it's from 0 up through 2. Cool. Okay. Oh, here, let's write the answer down. It was 0.892 for this particular problem. Alrighty. And then letter C actually is pretty simple. The expected number of members that are in favor, so that's n times p. Remember, the expected number is the mean. And so n is 5, and the probability is 0.72. And when I multiplied that out, I got 3.6. So out of those 5 members, we're expecting about 3.6 of them to be in favor of the change. Okay, I was kind of just looking back at it. It looks good. And now I'm going to simply tell you these formulas. The mean of x, we already know that. We just did it. It's NP. So it's mu again. And that's one we've been working with quite a bit here. And then the standard deviation is sigma. I was calling that incorrectly on some of the previous videos. Sorry about that. And I'm just going to tell you the formula. You kind of have this formula in your formula sheet, sort of. And by that I mean you really have the formula for variance, which is sigma squared. You have that one in your on your formula sheet. So obviously if you square this sigma, you will get sigma squared. So since you have this one right here on your formula sheet, you just have to know that the standard deviation is the square root of that, and then you'll be able to know how to find the standard deviation. And now we'll do a couple of examples. A fair die is rolled 12 times, so that means n is 12. And x is the number of 6s that could result. I like to write that down. Find the mean and the standard deviation. So the mean is NP, and n in this case is 12. And the p is the probability of a success, and a success is a 6. So the probability of getting a 6 on when you're rolling a die once is 1/6. 12 times a 6th is 2. So that's the mean. And then the standard deviation. So you're probably not going to have that formula memorized. You're going to look at your formula sheet. You're going to see variance and remember, oh yeah, I have to take the square root in order to get. You just have to remember that the standard deviation is sigma and variance is sigma squared, and so you have to take the square root of variance to get sigma. So anyway, That means that sigma is the square root of NP times 1 minus P. So I'm getting that from my formula sheet, since I'm going to be honest with you, probably not going to end up memorizing that. Now we have all the information we need. N is 12, P is, well, we already know. This part right here is actually mu, or not mu. Yeah, it is mu actually. It is mu. This is actually 12, or 2, but anyway. So you don't really have to recalculate that because we already did it. 1 minus a sixth is 5/6. So this is really 2 times 5/6. Take the square root of that. And I have worked this out ahead of time. If I can only find it. I do believe I got 1.29. That's probably rounded to 3 sig figs, of who knows. Okay, not too bad. If you can remember the formula, you have to, like I said, you will have to remember that standard deviation is the square root of variance, since they don't directly tell you the standard deviation formula. And the last example, 5% of a batch of batteries are defective. A random sample of 80 batteries, so that's N is 80, are taken without, with replacement. It has to be with replacement so that they're independent. Find the mean and the standard deviation of the number of defective batteries. So X is the number of defective ones. And sure enough, we know the probability of defective because P is the probability of the X's, 0.05. And now we can find the mean and the standard deviation. So again, the mean is mu, that's N times P. That's 80 times 0.05. And that, I think, was 4. Yes, that's actually 4. So on average, there will be 4 batteries that are defective. And then sigma, which is the standard deviation, is the square root of the variance. I mean, if you use this enough, it's a fairly simple formula. You'll probably end up remembering it, at least for the homework. NP is the mean already, so I already know that's 4. 1 minus 0.05 is 0.95. And then when we actually find it, I got 1.95 for the standard deviation. And we're going to learn about the normal distribution too, and kind of how the standard deviation relates to the mean. Okay, this lesson ends on a nice, fairly easy note. Not too bad. Great, we'll see you in class.